Alright, so this is our first set of notes in Unit 5. This unit, I like to start off by telling y'all this. This unit is called Quadrilaterals. Quadrilateral is any four-sided figure. Any figure with four sides. Meaning a square, rectangle, trapezoid, parallelogram, kite. All that we're going to talk about. Also, any four-sided figure that's kind of irregular shape too. But that's the name of this overall unit, Quadrilaterals. But these first 2 days, I'm going to teach you about all the polygons. Not all of them, but the majority of them. Any figure with 3 or more sides is considered to be a polygon. So starting from a triangle, going all the way up to any number of sides you can put on a figure. They're all called polygons, any figure with 3 or more sides. We're going to talk about all of them these first 2 days, and then after that we're going to shift over and we're going to specifically focus in on the quadrilateral, the four-sided figure. Alright, so that's where we at, that's where we heading. So this set of notes is interior and exterior angle sum notes. On the front we're going to do interior angle sum. So the sum of the degrees of any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look at the pattern to find the sum of the degrees. So we're going to fill out this table together, and then as we go you'll realize how to calculate the sum of interior angles, and you'll realize why they write the formula the way they do. Alright, so here we go. First polygon everybody should recognize is a triangle. The triangle has 3 sides. And then this part, it says number of triangles. They want to know the number of triangles we can create with a triangle. From one vertex to another, you can only make one triangle out of a 3-sided triangle. And the sum of the interior angles. Isaiah, you should know this. What's the sum of the interior angles of any triangle? We'll come back to you. We ain't got that kind of time. Go ahead, Robert. 180 degrees. I don't know why you don't know that, but we're going to keep moving. Next one, quadrilateral. This is any 4-sided figure. Quadrilateral. If you don't know how to spell it, I'll spell it for you. It's a 4-sided figure. Has 4 sides. The other question is how many triangles can be created from going from one vertex to like another on the triangle. In a quadrilateral you can create 2 triangles, and it's showing you right here. And the reason we're doing this, I can explain it now. Like, you'll notice all these figures kind of break back down to a triangle. That's why we teach y'all so much about triangles. All these figures that we're talking about, that we're doing now, can all be brought back down to a triangle if you split it enough. So 2 triangles can be created inside a quadrilateral. If that's the case, the measure of the sum of the interior angles is going to be 2 times 180, because 2 times 180 is 2 triangles. And that'll be 360 degrees. So quadrilateral adds up to 360. Because it can fit 2 triangles in it. Next one, 5-sided figure. What we call those? Pentagon. Pentagon has 5 sides. If you look over here, that's showing you from any vertex, you can create 3 triangles inside of a pentagon. That's the case, 3 times 180 will tell us what the measure of the interior angles would be, the sum, which is 540 degrees. Also, y'all gonna need calculators today, because I'm gonna be calculating a lot of stuff. So, and I'm gonna be asking y'all for help. So, next one, the 6-sided figure. What you call that, Devine? Hexagon. Hexagon, 6 sides. You can see over here, from a vertex, they can draw diagonals in and create 4 triangles inside of a hexagon. Since you can put 4 triangles inside, 4 times 180 720, thank you. Nobody ever knows the name of the seven-sided one. Let's see exactly. Huh? Who? That's what they call it? I don't think we call it that.
Sector 7.
Huh?
Sector 7.
But I don't think that's what we call it.
What else would we call it?
We call it a heptagon.
Octagon because it has 8 sides.
Why are you arguing with me? We call it a heptagon. Yeah. I agree with you, but that's what we call it. I think we can Google that. I'll Google it later. Y'all messing my video up. It is heptagon. Thank you, sir. You see why they arguing with me? Heptagon. Oh, after this, obviously we start drawing the pictures out because you can figure out the rest. How many triangles y'all think it's gonna have?
5.
Yeah. Okay, so 5 times 180 is 900. Next one, obviously we're gonna do an 8-sided one. Oh, everybody knows this one though. There it is. Please give her credit. How many triangles? 6. 6 times 180. That is 1080. We're just doing the main ones, y'all. We're not doing every last one of them. Next one, 9. 2 different words for this one I've seen. Well, the main one I know is nonagon. Oh, you about to tell me that? My bad. But I've seen them also call this, and I think on one of my posters they even call it. Matter of fact, they do. I don't even think y'all ever noticed that poster in this room. Y'all see that poster over there? Look at it. Y'all never look around. It got all the polygons on there. What they call it on there? Don't they call it like an entagon or something like that? Yeah, they call it something different. Yeah. So 7 triangles. There's 2 different words for this one. I don't know why. 7 times 180. 1260. 1260. You're right. 10. Decagon. Out of all of them, that makes the most sense. 8 triangles. Sorry. 8 times 180. 1440. Say it again. Oh no, I hope not. I don't even know what that is.
It's a 20-sided.
Oh, for real? See, I'm about to talk about that. Hold on. I'm skipping 11. I hope you ain't write this one yet. I'm skipping 11. 1, because I can't remember the name of it, and 2, I just want to do 12 anyway. 12 is a dodecagon. D-O-decagon. Has 10 triangles. 10 times 180. It's going to be 1800. Right. Yeah, mentioning that before we move on, Robert. At a certain point, we stop naming them. We don't try to. We're not even gonna make you memorize all these. Like, we won't go past octagon if we ask y'all a question. We won't go past octagon if we ask y'all a question. But after you get to a certain point, we stop even using the names. We'll just start using numbers, literally. Even if you look on the back of these notes at the top. Number 1 and 2. Number 1, we call it a 15-gon. Number 2, we call it an 18-gon. Like, at a certain point, we'll just literally just put the number there and put gon afterwards. Like, we're not going to sit there and try to do all the names for all these figures. I don't even know all of them. Alright. So this was to do 2 things. Give you a reference for the most common ones we use. Also, so you can figure out how we find the sum of the interior angles of any polygon. There's a formula that we use, but you kind of just derived it by doing this up here. The formula is, if n represents the number of sides of a polygon, the sum of the interior angles can be found using this formula. But we kind of just did it up here. Basically, it is whatever your figure is, however many sides it has, your triangle, number of triangles is 2 less than the number of sides. and then you multiply by 180. The formula is this: n minus 2 in parentheses times 180. This is how you find the sum of the interior angles of any polygon. Sum meaning all of them added together. N minus 2 times 180. But the n minus 2 comes from this. Number of sides minus 2 to tell you how many triangles it has. And then you multiply by 180. That's the easy one. This one ain't hard. It's pretty much the same. Y'all just get these two mixed up and don't know when to use them. So I'm going to try it. Actually, it's been going good today, so hopefully it goes good for y'all. Interior angle of a regular polygon. So if they call a polygon regular and they want to know what each angle equals, you can tell them that. But they have to call it regular first. The reason they have to call it regular means that all the sides and all the angles are equal. Basically it means if they call a figure regular, they're telling you it's equilateral and equiangular. That doesn't just go for triangles, that goes for any shape. If I call a quadrilateral, a four-sided figure, equilateral and equiangular, or I call it regular, I'm telling you basically that it's a square. Has all the sides are the same, all the angles are the same. If I do that for a pentagon, I'm telling you that the pentagon, all the angles, all the sides are the same. If I call it regular, I'm just telling you it's equilateral or equiangular. That's what regular means. Anytime you see regular in this stuff, they're just telling you, okay, all the sides, all the angles are the same. Matter of fact, that's the piece that's missing down here. A regular polygon is one in which the sides are equal, therefore all angles are equal. To find the measure of the interior angles in a regular polygon, use. So first we're going to find the sum by doing the n minus 2 times 180. But then we want to know what each individual angle equals, so we need to divide that by the number of sides, n. So it's n minus 2 times 180 divided by n. That's the extra piece you got to do to find each individual angle on a regular polygon. You can only do this on a regular one though, because all the angles have to be the same. Moving on, let's do some stuff on the back real quick. Number 1, find the sum of the interior angles of a polygon, of a 15-gon. My bad. The things I need y'all to read is to make sure you can answer my questions correctly. This one, it says find the sum of the interior angles. So this is all the angles added together. They want to know sum. This is what we were doing at the top on the first page. All we're doing here, n minus 2 times 180. So I want to find the sum of those interior angles. Doing that, 15 for n, that's the number of sides, minus 2 times 180. 15 minus 2 is 13. 13 times 180, thank you, 2340. This is the sum of all the interior angles of a 15-gon. Number 2. Question is a little bit different. You need to make sure you answer correctly. It says, what is the measure of each interior angle of a regular 18-gon? So on this one, they want to know what each interior angle on a regular. The first one's asking us for the sum of the interior angles. This is want to know what each interior angle of a regular 18-gon is. This one is the one where you use n minus 2 times 180 divided by n. You need to find out each interior angle. For that, n is 18, so 18 minus 2 times 180 divided by 18. Thank you, Tim. So it's 18 to minus 2, 16. 16 times 180. Divide that by 18. Tim said he got 160. 160 degrees. So each individual angle on the 18-gon, the interior angles, will be 160 degrees. Y'all gonna see me calculate that too when we do a problem a little bit later. So I'm gonna do some of your practice with you because I don't trust y'all. Exterior angles. These are the outside angles. Y'all should know this. Exterior angles are always supplementary. Keyword there. Supplementary meaning what? 180, right? To their adjacent interior angle. On the polygons below, find the measure of each exterior angle along with the sum of all the exterior angles. Tim will come for you for the hexagon, so work on that one. I need some people with calculators because y'all gotta help me. All right, but let's you and I do the first one. Triangle. I'm gonna zoom in. So Robert, they give me all the interior angles here. They want me to find the exterior angles and then add them together and find the sum. Let's start with 61 right here. This is interior. They say the angle next to it is adjacent to it and they're supplementary. What's this exterior angle right here? 119. For those who don't know how we got it, you shouldn't be confused. 180 minus 61. That's all we're doing. All right, on 79, what's the angle, exterior angle next to it? 101. 40. 140. Now, Robert, I need all three of those exterior angles added together. I need to know what they are. $360. Zach, you look like you're ready. Let's do a quad. Zach on the quad. I'm gonna start with 71 right here.
That's
109. 124.
That is
56. 76.
That is
104. And 89.
That would be
91 degrees. Zach, all four of those added together, those exterior angles, what do they equal? You're missing something. I'm typing something. It's 360. You got it now. So that one's 360 as well. Well, you punching in the calculator, so I might as well bother you. Sharonica, Pentagon. I'll call them out. Tell me what I need to write. This one with 104. 76. 98. 82. 121. 59. 87. 93. And then 130. Did you add all of them together yet? $360 degrees. I think a pattern is forming, kids. Tim, you ready? Let's get it. Let's start with 117, Tim. 63. Hold on. 115. 65. 129. 51. 124. 56. 112. 68. And then 123. 57. And Tim, what did you get for your sum? There it is. Now Tim, let me ask you this question. What do you think the sum of any set of exterior angles for any polygon would be? 360 degrees. This is the lesson, kids. This is what we're showing you. No matter what shape you got, if you're dealing with exterior angles, it's always going to add up to 360. Interior is different. Interior is the stuff I showed you on the front. Interior angles, those are going to add up to different things depending on how many sides you have. But your exterior angles are always going to add up to 360 degrees. I say that because I want that to stick. Some kids, there's literally, I think, a question on the test where it's just like, they give you, they ask you what's the degrees of each exterior angle. All you gotta do is 360 divided by whatever shape they give you. And people get that jump wrong because they don't remember to use 360. Exterior angles, man. Exterior angles practice. 3. What is the measure of each exterior angle on a regular hexagon? It's exterior angles, and they want to know what each one of them is. And they call it regular, so that means all sides, all angles are equal. Hexagon, how many sides does it have? 6, right? So I'm doing 360, well, divided by n, which is my number of sides. So 360 divided by 6, which is 60 degrees. And then number 4, you just need to recognize this is asking the question in reverse. On this one, it's saying if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So on this one, they give me the degrees of an exterior angle, and they want to know, okay, how many sides does this figure have? Going in reverse, but you still do the same thing. So it's going to be 360 divided by my exterior angle. I'm going to abbreviate this. Whatever angle they give you. So they gave me 12 degrees, so I'm going to do 360 divided by 12. And this is going to tell me the number of sides my figure has. 30. Figure has 30 sides, which is a lot, but a figure can have 30 sides. Number 5. I really want y'all to key in on this one because it's the kind of question we like asking y'all on the test, of course. Because it mixes skills. It's talking about the stuff from this unit, but also reflects back a little bit. So it's given a regular polygon on the coordinate grid. Which transformation will place the figure back onto itself? Select all that apply. So they want to know, out of these transformations that they gave us right here, which one will flip this polygon, which is a hexagon, back onto itself. To figure it out, we got to go through and test it real quick. It shouldn't take long. Before we do that, let me read stuff so you can understand. Y'all should know what all transformations you see here. This first one, this is a reflection over the y-axis. Second one is a rotation of 122 degrees. Third one is a reflection over y equals x. Y'all should remember that it's the diagonal reflection. And then the third one is a rotation of 60 degrees. Let's focus on the 2 reflections first. The first one says a reflection over the y-axis. Y'all should know what the y-axis is, but if you don't, I'm going to highlight it for you. Y-axis right here. They're asking us, can this image flip over the y-axis and land on itself? What you think, Jake? Huh? So this won't flip over the y-axis and land on itself? Yes, it will. It will definitely be one where this will flip over the y-axis and land on itself. So we would definitely want to check that. The next one, let's do the other reflection. Y equals x. Remember, y equals x is that diagonal reflection. It's kind of hard to see from the way this is drawn on here, so I would put my line on. Remember, the y equals x line has a slope of 1 over 1. So it's up 1 over 1, up 1 over 1, up 1 over 1. And I would just draw the diagonal, and I think it'll help you see it a little better. Off a little bit, but we can get it. So once I draw this diagonal in, we're looking to see if we can flip the figure over this and it land on itself. Colin, what you think? Can this flip over this and land on itself? Some people saying no. Looking at this, I would say no too. I'm going to tell you where the issue lies at, Colin. It's kind of hard to tell, but you can see it right in here. You see this segment right here, Colin? Yeah. This line would need to be in the middle of it. Don't you agree for it to flip over and land on itself?
I figured the other side because it was on the other side.
I'll show you. I'm going to even show you what happens, Colin. Let's put points on here. Say, Colin, say this figure was labeled and this was point A. When we get ready to reflect this over this diagonal, point A prime, so point A is down here, is 1, 2, 3, 4 away from the line. You see that, right? A prime would be 1, 2, 3, 4 away over here. This is where your A prime would be. It doesn't even land on another point, it just lands up there. You see what I'm saying? So this definitely wouldn't flip over and land on itself. So we don't want to choose that one. And then the other two are rotations. Now these aren't the regular rotations that y'all seen. I only taught y'all 90, 180 or whatever, and 270. You don't have to worry about that. The do rotations is easy on this. The figure is rotating from 0, 0, the center of it. We're just trying to figure out where to rotate and land on itself. To figure out what rotations it can do, first you need to start with what you should know. What's a full rotation? 360 degrees. Let's start there. Full rotation is 360. To figure out what rotations this figure can do, I'm gonna go by the number of sides that it has. It has how many sides? 6. Got 6 sides. That means 6 different rotations this figure can do to land on itself. I'm gonna figure out where they are. 360 divided by 6 is what? 60, right? What that's telling me is every 60 degrees this figure will land on itself. So I know it can do 60. 60 plus 60 is what? 120. 120 plus 60, what's that? 180. 180 plus 60? 240. 240 plus 60? 300. And then 300 plus 60. I just showed myself all 6 rotations that this figure can do. So I know it can do all 6 of these. So over here, I'm just going to look and see which ones they got on here, and I'm going to check those. Can it do a 122? No. Can it do a 60? Even if any of these, like if 240 was an option, y'all need to check that. If 300 was an option, you need to check that. Any rotation that it can do. But we just listed all the ones it could do. Alright, let me pause real quick. I'm not going to end the video, I need to pause. And we're back. Alright, we're going to look over some practice stuff real quick. I just want to go over a couple problems on here. First, I'm going to start up here so y'all don't screw my formulas up. This is a review of the formulas that we went over in those notes. The first one, sum of the interior angles of a polygon. This is the first one I gave you. This is the n minus 2 times 180. This will give you the sum of all the interior angles of any of your polygons that you need to know. The second one is interior angle of a regular polygon. This is if you have a polygon and it's called regular, meaning all the sides and all the angles are congruent. You can find each individual angle, which would be n minus 2 times 180 divided by n. And then the third one, not necessarily a formula, just something I needed you to remember. Let's see if you remembered it. Shaylee, what's the sum of the exterior angles of a polygon? Yeah, what's the sum of the exterior angles of a polygon? Just you overthinking. There ain't even a formula. Go ahead, Sharonica. 360. The sum of the exterior angles of a polygon is 360 degrees. Exterior angle of a regular polygon. So say they want me to find an individual exterior angle of a regular polygon. This is when I would do what? Okay, go ahead. 360 divided by n. Thank you, man. That's all good. And then the last one, say if I wanted to know the number of sides of a regular polygon and they gave me the angle, I'm going to do 360 divided by the exterior angle. Make sure it's the exterior angle too. The interior angle ain't going to help you find that. Alright. So down here, I don't want to do these for you because you can do these on your own. 1 through 3. There is an example of each one of these in your notes. The first one is asking you to find the measure of each interior angle of a regular octagon. You should know how many sides they have. You should know how to find each interior angle of a regular one. The second one is asking you to find the measure of the exterior angles of a regular 20 gun. That's in your notes too. Third one is asking you to find the sum of the measures of the interior angles of a 27 gun. You should be able to do all those. The ones kids get stuck on is number 4. I want to look at 4. It's the one where kids always ask me for help on, because you just haven't seen it asked this way. It says the sum of the interior angles of a polygon is 1620. So basically, they're giving me the sum. They're telling me a figure has 1,620 degrees. They want to know how many sides does that polygon have. So they basically want me to go over in reverse. They're giving me the sum of the interior angles. They want me to tell them how many sides it has. What kind of sided figure is this? To do that, I must still use the formula for sum of interior angles. The formula for sum of interior angles is the very first one up top there, which is n minus 2 times 180. Only thing is, I don't need to find the sum. They gave that to me already. So I'm going to say this formula equals 1620. And then from there, I'm going to solve an equation. We in Unit 5 now. We should be real tight on our algebra. On this equation, let me tell you what I see. It's n minus 2 in parentheses. So I got to respect that. And then it's times 180 equals 1620. The first thing I would do, I would divide by 180 to get this 180 away from there. I'm solving for n. I would divide by 180. Canceling that over here. On this side, 1620 divided by 180. What you say? 9. So I'm going to get 9 over here. I'm going to bring down my n minus 2. I can drop the parentheses now because that's all that's left. N minus 2. So I'm going to add 2. If you think about it, all we're doing is what we did the other way, just in reverse. And I'll explain that after we solve. And so we did plus 2, n equals 11. We just reversed what we've been doing to solve for the number of sides. So it's 11. It's an 11 gun. If you think about it, the regular way would have been, say I would wanted to find that interior angles. I would do 11 minus 2 times 180. Well, they gave me some of the interior angles, so I just need to go back and find the sides. So I'm just going in reverse. I'm dividing by 180 and I'm adding 2. That's essentially what I did, reverse. Alright. 5 through 10, y'all have trouble on some of these. Not really. Once I show you a couple, I think y'all be good. The main issue I have with kids on these, I don't know what equations y'all be writing. Like, y'all just be making up anything. These are polygons. I showed you how to calculate the interior angles. The main thing you gotta do first is figure out what you need to set your stuff equal to, or what the total is gonna be. A lot of kids don't do that. They just be making up stuff. So number 5, I see I don't know how many sides this figure has. Anybody counted it? What, 7? Yeah, it's a 7-sided figure. So it's a hexagon. And then on here, they want to know the value of x. They gave me all these other angles, including this 90. You should include that. That is a 90-degree angle. They gave me all these other angles right here. They want me to find x. Well, to find x, I first need to know what this 7-sided figure adds up to. It is on your first sheet over there, but just to remember how to calculate it again. If it has 7 sides, we're doing n minus 2, so 7 minus 2 times 180. And what you say? Yeah, 5 triangles, so 5 times 180. What is it, 900? Yeah. 900. So this 7-sided figure adds up to 900 degrees. That's good to know. Now that I know that, I can add all these things together, subtract from 900, and I'll get x. But y'all know I'm going to write an equation because that's just what I do. When you add all these other angles together, these other 6, you should get 806. 806 plus x equals 900. Subtract 806. X equals 94. Six is similar. 6 is just a quadrilateral though. Y'all should just start remembering how much a quadrilateral adds up to. Any four-sided figure is going to be the same. If you don't know though, I will say it has 4 sides. Now I'll say 4 minus 2 times 180, 360. So this should add up to 360. Alright, I'm not going to solve this one though. Y'all can do that. But total should add up to 360. Let's flip to the back. Let me get another one going. Hold on. Yeah, number 7. That's another one y'all get stuck on. But I'm going to unstick you right now with a good behind explanation. Hold on. We're almost there. Number 7. A couple things I want you to notice. They want us to solve for x. They only got this one expression right here, 10x plus 4. Another thing you should notice about number 7. All these sides are marked congruent to each other. If all these sides are congruent, what does that mean about our angles? They're all congruent, right? This is a regular figure, whatever it is. I don't know how many sides it has. Anybody counted that yet? It's a decagon then. She said this has 10 sides, so it's a regular decagon. That being said, I know all these sides are congruent, and I know all these angles are congruent. These obtuse angles in here, I know all of them are congruent to each other. Even the one that got 10x plus 4 on it. I'm telling you that to say this. If that's the case, if all those angles are congruent, I can find what each individual angle equals, and then I can just write an equation using that one angle. So that's what I'm gonna do. You just gotta make sure you use the right formula for it. The formula for this one is gonna be n minus 2 times 180 divided by n. And y'all called this a decagon, so y'all said it had 10 sides. So we're doing 10 minus 2 times 180 divided by 10. 10 minus 2 is 8 times 180. That's 1440. And then divide by 10, you'll get 144. Alright, so 144 degrees. And then from there, now I know all these individual angles in here equal 144. 144, 144, 144, 144, all the way around. Even this one that we got 10x plus 4 on. If that's the case, 10x plus 4 equals 144. Then you can solve for x. X equals 14. I'm not going to solve it anymore, but I do want to mention 2 more with you. Number 8. On this one, looking at it, you got numbers and expressions inside. They want you to solve for x. Obviously, you need to write an equation. You just need to make sure you set your equation equal to the right thing. So on this one, number 8, I'm looking at it, it has 6 sides. So I'm saying 6 minus 2 times 180. What is it, 720? I don't know. 720? Okay. 720. That's the case. All these added together equals 720. That is the equation y'all need to write down here to solve. This plus this plus this plus this plus this plus this equals 720. Yeah, it's a long equation. I don't care. Add them all together, combine like terms, make sure you solve correctly, solve for x. Then, the other one I want to mention, number 9. Let's see if we can get Isaiah some redemption. We probably can't, though. On number 9, I'm not even going to ask you to solve, but I'm just going to ask you basic questions about this. Isaiah, on number 9, I'm looking at this figure, and I'm looking at these angles. All these angles that they're showing me, what kind of angles are they? Yeah, everybody whispering it to you. These are exterior angles. Don't whisper nothing else to them, y'all. What should you know about exterior angles that'll help you solve this? Trenton got his hand up. Trenton, what's up? Oh, I'm about to cuss on camera. Yes. All these should equal 360. So your equation is going to be all those added together equals 360. Thank you for paying attention, sir. Alright, that's it for me on that. Let me stop video. Alright, anybody watching the video, you can always go back and watch this again if you need to see any other things. Hold on, let me stop my video.